Once again, good evening, everyone. Sorry for the delay. There is some network issue on our side also. So we have our expert, Dr. Mr. Lukesh Sahu, sir, with us now, and it's time to proceed to for our session. Hello, good evening, sir. Welcome once again.
Good evening, Swati ma'am.
Yes,
Hello,
sir.
everyone. Yeah.
Okay, so it's my honor to introduce our expert
Okay.
speaker for today's session, Mr. Lukesh Kumar Sahu, the senior software developer at the TCS Nagpur. Sir has over 10 years of rich industry experience in software development and has contributed to the design and implementation of intelligent and scalable systems solutions using advanced technologies. Today, Sir will be speaking on a very important and emerging topic, Edge AI integrating the machine learning with IoT. His session will help us to understand how the combination of machine learning and the Internet of Things is enabling the smart real time decision making at the edge, improving the efficiency and performance in various industrial applications. We extend a warm welcome to you, sir, and we look forward for an insightful and interactive session. Once again, welcome, sir.
Thank you. Thank you, Swati ma'am.
And if you are with your due permission, if you want, we can start the session, sir. Now,
Yeah, sure, sure. Good.
yes, sir. Yes, sir.
So, okay. So, thank you all and welcome you all as well. So, let me share my screen quickly. Okay. So, today we have the topic that is AGI integrating machine learning and IoT. So before starting the sessions, I just want to ask you all something like someone is aware about that. What is cloud? What is cloud provider? So that is a basic one. So I want to just ask you that don't worry about that. I'll explain you that thing as well. But I just want to see if someone having that kind of information as well.
Yes, anyone? So, can you repeat the question
Yeah,
for?
sure. So what is cloud and who is cloud provider in our world? That means some cloud provider is having. So who is providing the cloud services to us? Because we are always looking into that in generative AI, in AI, the cloud is always there. So what is cloud? First thing.
Sir, excuse me, cloud means
Mhm.
so the general cloud service providers are Amazon Web Service,
Exactly.
Google Cloud Platform
Mhm.
we have. So whatever
Exactly.
we can save our files in the on the cloud.
Mhm.
That's
Right. Right.
yes.
So, in some simple terms, we can say that clouds is a storage space. We can say that. So, the cloud provider services is AWS, Azure, and GCP. These three are providing the cloud services. So, they are providing many of the services in the cloud, like storage, like computational infrastructure, each and everything they are providing to us right now. So, without a single machine installations, they are providing a cloud services. So this is the thing for the cloud. So next, let's move for the Edge AI Internet of Machine Learning with IoT. So what is Edge AI? So Edge AI is a combination of artificial intelligence and Internet of Thing technology. Internet of Thing, that is a technology, or uh, it's connected with some devices. Okay, so like we are creating some models in ML. ML is machine learning. Machine learning, what it does, it is collecting the informations and processing with the basis of some conditions. They have the ample of data, then algorithm will be applicable in the machine learning, and it will be deployed. Then it will connect it with some devices. Okay, devices like we can say that sensors, camera, microcontroller, and etc. Okay, then it will be communicated that, and you'll get the result. So before I'll explain you the further things, I'll just take example. We right now we all are surrounded by the AI or IoTs. Okay, so let me take up one example. We are booking a tickets in IRCTC platform, and always in some festival seasons like Holi, Diwali, Eid, every festival seasons we are booking the train. And earlier, what happened? Earlier, the person is booking the train. He don't know this that ticket would be clear or not if it is on waiting list. So they don't know it would be clear or not. So uh, they they will not be planned to move somewhere else if the ticket is not been clear, right? But nowadays, with the help of IoTs and AGI, we have the probability of the ticket will be confirmed or not. So as per that, we can decide we will be planned for go somewhere else or not. So that is a one example. So we have so many of example. Okay, so how that will be communicated, AGI, and what things we need to do, I'll explain you later in these sessions. But yeah, before anything I would need to explain, I would give you ample of example so you can connect with that architecture as well. So how it would be used, how it would be communicated to each other like that. So with the help of this IoT, many of the things will be easy to the human life. Like you have seen like Google Home, right? So what it does, Google Home, we have the many advertisement nowadays in the TV, we have the heater, we have the cold water, right? So that all are the basis of IoTs. Okay. So nowadays, let me give you some more example. Okay. And what is the benefit of that? Integrated AI with IoT. Reduce latency. That means we can reduce the time. We can, if we are predicting something, like as I explained for IRCTC, we can make the decision, right, on the basis of this thing. And also enhance the privacy and security by keeping sensitive data on the device. Suppose we are keeping something, so we can also, with the help of that, we can secure our data. We can improve efficiency and lower bandwidth cost. So what did it mean? It would not uh, it would not require the bandwidth of internet. Okay, that means it would not require 100 Mbps speed like that, and it would not require so much of cost to connect with a device. Device, it means IoT's device. Okay, so that is a thing for IoTs, and we can enable, we have the real time decision makings for this one. Okay, so now let me give you one more example. So I'm just giving a live example how IoTs work with the AGI, okay, with the artificial intelligence. In the desert, they are also farming, okay, but in the desert, the temperature is very huge. So how they are maintaining when the water should require for any plants, okay? So they are using one device, that is a temperature device, okay? And that temperature, once the temperature is so much, then it would just flowing the water in the plants. Okay, once that means any volume of water that would be supplied in the plant. Okay, on the basis of that sensor. Sensor would be communicating on the basis of AGI, and it would be communicated with the cloud. So a device giving you the informations. Okay, so and for device, we have created some machine learning code. Okay, so we have the permutation and combination. Only device give you the data, and that data you can filter out. That means what when you can flow the water, the temperature, then all the data would be containing in the with the help of device. Okay, that IoT device, and that IoT device communicating with the different layer, that is communication layer with the cloud. So it will give you the informations, and accordingly you are just action on it. Okay, so similar way we have another example, that is a traffic controller. Okay, in a metro cities like Mumbai, Pune, Bangalore, Delhi. So in the traffic, there would be huge traffic on uh, 9 a.m. that is office time for all the ITs, and evening 6 p.m. Okay, 9 a.m. and 6 p.m. there would be huge traffic. So between the, you can say that 9 to 10 a.m. that would be huge traffic, and evening 6 to 7 p.m. that would be huge traffic. Okay, so how the traffic controller will control with the help of this IoT? They have set up that cameras. Okay, so they are collecting the data. That camera detect the person, how huge they are. Okay, in which time. So that data will be going to the cloud, and there they are making the algorithm. Okay, they are making the algorithm, so in which time we have so many of peoples traveling from home to office or office to home. So accordingly your signal will be work. So suppose your signal is for 30 seconds, so on the peak time, that would be 1 minute. So it would be no human, without human, that would be working on that. Okay, that is a second example. So any questions, any if someone is not clear about how it working, or anyone having any questions in example 1, example 2? And how this helping in our life, like reducing the congestions. Okay, faster emergency response. So all we have the benefit of this IoTs. Okay, we can improve our service. We can, with the help of that, we can do a more crop. Okay, in agriculture, in every sector, we have used these IoTs right now. So these are two examples. I'll give you some more examples in the for the slide. But yeah, till now, and anyone having any more example, so he can share with us as well. In nowadays, because we have surrounded by the IoTs devices, we can see everywhere in the advertisement, in surrounded by us. And very soon in Chhattisgarh government as well, they will be implemented this IoT in our cities. Yeah, so let me go to next slide. The key application of AGI. So smart manufacturing. Okay, so in smart manufacturing, like let me take one example. In car, uh, earlier we were using some different things like to cool our engine, so we were using that radiator. So nowadays we have a coolant. So similarly we have many chips involved in that car. Okay, so similarly we have the different sensors like temperature sensors. Okay, so what it does right now in temperature sensor, once it would be overheating, and you drove your car so long time and it would be overheating, then your speed so your sensor will give you, yeah, it is overheated, just slow down your speed and just take a break. So that sensors will do. Okay, and nowadays it would be implemented with the our mobile phone as well. You can operate your car engine as well through the mobile. So that is the IoT. Okay, with the help of that, so many sensors have connected with your cell phone, your so there will be server, there's many things has been communicated with that. Okay, in healthcare, in healthcare patient monitoring device. Okay, smartwatch is a AI, AGI. Okay, so how it works, it will give you the response like the ECG patch. Okay, the steps, how much steps you have done. Okay, so it would independently, it would be working, but once you enable uh, your internet in your mobile, then all the data will be transferred to your mobile, right? So that chips has been enabled with the IoT. That chip, we can say that that is a IoT device. Okay, similarly we have many things, many in healthcare area as well, the ECG machines, the oxygen machines. So many hospitals also using these IoT devices. Okay, then I have already been explain you about the smart cities having the traffic lights can be adjusted automatically based on the traffic flow. So that is also maintained by the only the AI will be will decide, okay, in which time, as per the traffic flow, it will slow and fast, it will increase the timing, it will adjust the time in the traffic signals. Okay, now in the agriculture as well, the AGI sensors, as the temperature sensors we can use, as I give you the example for the desert. Okay, similarly in agriculture as well, AGI sensors monitor the soil moisture, temperature, and crop health as well. So with the help of that, in each sector, we can improve our uh, productivity. Okay, in automobile sector, in agriculture, in healthcare sector, and manufacturing sector, in all the sectors, we can improve our services. We can improve our productivity with the help of that. Okay, and in automobile sectors, how they reduce the manpower. Okay, in we have so many of automobiles in the automobile sector, so many of brands. Okay, so one car, one bike, one auto, how much time it would take to prepare one auto? Okay, it would not more than 30 minutes. Why? Because they are using with the help of robots, with the use of IoTs. So they will be having some coding behind that. Okay, and based on that, they are working with a less manpower. So, so in industrious robots, so robots use on-board AI for objects recognitions, quality inspections, and assembling the parts as well in the automobile sectors. So nowadays, it's a part of our life, that AGI. Okay, with the help of that, we can improve each and everything, the productivity, that services in our area, in the different area as well. Okay, so nowadays we are uh, we are establishing the CCTV cameras in our institute, in our organizations, in our home itself. So we can also use that data uh, on the basis of these IoTs. Okay, so we can make a code behind that. Okay, we can that means for more secure. Okay, we can do that. You can just think about it, how we can do that. Like traffic signals, it's a just on the basis of the traffic flow, the light will be adjusted. So similar way, we can also use that in for the CCTV camera in our home as well, right? So we can think about it, how we can use it. But yes, this is a part of our life, and we can improve the services, we can improve the productivity. Okay, so any questions how the IoTs work, and what is examples, in which sectors we can use it? Okay, so I'll give you then picture how the architecture works for AGI. Okay, so let me move further. So AGI architecture. So AGI architecture is categorized in three parts: data collection, edge processing, and cloud integrations. Okay, so data collections. So the device, what we have installed, like for desert, okay, like for CCTV camera, that all are the devices. So data collections. So IoT sensors capture environmental or operational data. Okay, so we can say that all are the devices. So IoT sensors capture environmental or operational data. Okay, that data will be processing through uh, some technology, that is, we can say that machine learning. Okay, so now it will be moving to edge processing. Edge processing, what it does, on device machine learning inference using framework like TensorFlow Lite or OpenVINO. So you can simply, I'll not deep dive into the complete technology, but yeah, with the help of machine learning having so many of permutation and combination, then on the basis of that, it will give you some results. Okay, what you will decide. So on the basis of this, that machine learning, it will you can decide it. Okay, now cloud integrations. So the model update and analyze analytics performed in the cloud. Okay, so cloud basically used for the storage, as I said, and many services also provided by the cloud services. So once once the ML will decide, okay, the conditions on the basis of that, like the temperature is temperature, you use what you need to do, what action you need to do, temperature is low, what action. Mhm. What action you have to perform. So it will moving to the cloud. Okay, the model update and analytics performed in the cloud. So you can in the cloud integration, simply you can analyze on those, and you can take a decision. Okay, so this three component would be required, and feedback loop, the continuous improvement it would be doing. Okay, if any issues, then it would trigger something, and on the basis of that, we can fix those issues. Okay, so machine learning basically is algorithms. Okay, on the basis of that algorithms, it will give you the result, like on the diagnose perspective. Okay, in a hospital, a patient having a cancer detected a cancer. Okay, and on the basis of the history, on the basis of so many of permutation and combination, on the basis of the data, machine learning, it will decide the detection, that mean the improvement of the human is positive or negative on the basis of the data, on the basis of the past result. So now the machine learning is so much important for the IoT and AGI. Even nowadays, so many of functions would be implemented in Python, in Java, that is built with the help of machine learning. So there is a flow for the IoT, how it would be communicated. IoT is a device. You can just take an image like sensors, camera, okay, and meters. That are the devices where we have installed the IoTs. You can say that IoTs. Okay. I'll give you some more example. Let's take one example. We have we are getting a water, okay, in office, in institute. So if you are just putting your glass, you have a water. Once you remove your glass, your water tap will be off. Okay, so how that is working, that is working on the basis of this IoT sensors. Okay, so that sensors will be working on the basis of some object. If some object will be there, then your tap will be on. You once you remove your object, the tap will be off. That is IoT. Okay, So that's all the enough example. If I'll be having any more example, I'll give you in mid of the sessions as well. But yes, let's move further. So IoT devices and layers. So we have the sensors, camera, and meters that all are the IoT device. So that capture the data, like camera capture the videos, images, and sensors capture the data like temperatures related or something else also. Okay, object related data. So all the data will be captured through the devices. Then that data will be moving to the edge gateway. Okay, so pre-processing process. So here it will take actions on the basis of some data. Okay, we have this data, and that data will be storing in the cloud server. Okay, then it will preparing the dashboard. That means you can see that data, and on the basis of that condition, that suppose you want for the traffic, you can check the flowing time. On the basis of that, the IoT device will be interactions. Okay. Then similarly, again, it will be processing the data. Then on the base of decision, it will reflect the actions, the IoT device. Okay. It will provide the data to edge gateway, then gateway processing the data. It will be giving to the cloud. Then cloud, again, it will be giving the communicate with the edge gateway. And for the action, the IoT device will be taking actions on the basis of that. Okay, so it is a vice versa. The both the flow will be interconnected. So once you'll be having the data, it will be moving to the edge gateway, then cloud server. Then once you have all those things, we have to prepare the model. What actions we would need to take. Then it would again go to the edge gateway. Then it would ask to IoT device. Yeah, this action should be required. Okay, so there is the architecture. Then let's deep dive into the layers, how it works. So first layer is a device layer. As I said, the component like IoT sensors and the cameras, embedded boards, this all are the devices. So Raspberry Pi, this is basically used for the sensors, okay, nowadays, and the second one as well. These are using for the sensors, like in agriculture, like in automobile sector as well, for any temperature purpose. Okay, so we are using that one. Functions, the collect raw data. Okay, the temperature, image, vibrations. Okay, and etc. Suppose in the rainy season as well. Okay, so it would be capture the vibrations. So on the basis of that, it will take a decision. So what we have to do? Okay, we cannot flow always the water in the plants. So it would take a decision on the basis of the on the basis of the conditions. Okay, so here again we have the example like a temperature sensors detecting the overheating in a motor. Okay, as I give you the example in the car. Similar here we have the example for these layers. The second is edge layer. Edge layer, so edge server. Okay, we are capturing some videos, okay, some temperature related data. So it will be storing here, okay, edge server, gateways, or smart routers with a higher compute power. So it would flow the data to the cloud as well. Okay, functions runs AI interfaces, this TensorFlow Lite, okay, Open Vino, NVIDIA Jetson. Then perform data filtering, aggregations on the local decision making. So once your data will be ready ready in the edge layer, so the data, a few data will be filtered. You cannot show the dashboard with the base of the all the data, right? So the filtering will be performed in the edge layer. So it will perform the data filtering, aggregations, then it would be showing in your dashboard in the cloud. Okay, then sends only relevant summarize to cloud to reduce the bandwidth. Okay, so that's why I said, so it would not require so much of bandwidth. Okay, it would reduce the cloud, it would reduce the bandwidth because it would not giving you the full data, it would giving only the filtered data. So on the basis of that, it would not take so much of cost as well. So in the example, an edge gateway analyzing video feeds to detect defective product on the assembly line as well. Okay, so we can use each and everywhere as well, and in the foreign, in the shopping market as well, they are using the uh, AGI. Okay, so suppose so many of people are purchasing the groceries in the shopping mall, and uh, so each product, once you are selecting, so IoT will detect, yeah, this person is taking the 40 items, so no need to standing in the queue for your billing counter. So already you have picked up the 40 items on the on the barcode basis. It would be scanned, and you have to only pay, not to stand for the billing counter for the complete scanning for the all product again. So with the help of that AGI, the life is very easy in future as well. So now the cloud layer. So this is the third layer. That is, as I said, there are three cloud services we have. That is AWS, Azure, and Google Cloud. Any one cloud services we can use it for centralized data center. So all the data will be there. On the basis of that, our IoT device will be responses. Okay. So what we want, okay, centralized data center or cloud platform. So that data will be uses in the machine learning, and machine learning, how it would be taking the permutation and combinations on the basis of that data. Then it will decide, yeah, what actions should be done. Okay, so that decision making on the basis of this machine learning. Okay, so perform AI model training and retrain with a large data set. So everywhere the data would be required, everywhere. So on the basis of that data only we can decide what action should be taken on the basis of that, and the device, how what action they can take and what action we can take. Okay, then provide the dashboard analytics and system management. Okay, so example, the cloud retrains a predictive maintenance model using a new factory data and redeploy it into the edge node. Okay, so here we would be, as I said, we have these three layers, our edge layer, data layer, and cloud layer. Then once you will be having all the data, then it would give the instructions what actions should be take. Then it would again it will be back to edge layer. Then edge layer will respond to our devices. So it will take actions on the basis of that. So these are three layers. Okay, then challenges in AGI. So we have the limited computational resources on AGI devices. Okay, model compressions and optimizations for development. Okay, so nowadays it is initial phase. Right now we can say that, but in future, uh, all the human will use on in the daily life this AGI, because it is required for the future. So we can reduce the time, we can reduce the cost, we can improve our securities as well with the help of this AGI. Okay, scalability and interoperability across diverse IoT hardwares. Okay, so now it is working, and many sectors are also using, but uh, they are working to reduce the size of that device. They are working to improve the hardware capabilities. So in future, most probably will be on streamline, and everyone will be, the IoT will be part of everyone's life. So anyone can give me some more examples if someone having, or If anyone having any questions, just let me know. Otherwise, I'll explain what machine learning having and how it works in AGI. Till now, anyone having any questions for the different sectors?
No, sir. No question from my side.
Okay, thank you. So machine learning and Python or Java, we can say that any language, if anyone knows, then they can implement the IoTs as well. So machine learning, what it does, machine learning is a transformative technology that enables system to learn from data and improve their performance over the time without explicit programming. Okay, by identifying pattern and making predictions. Okay, ML is widely applied across various industries to automate tasks, enhance decision making, and extract valuable insights. So as I give you the example of healthcare. So machine learning is a algorithm. Okay, so many of algorithms will be there, and on the basis of data, it will give you the results. It will automate all those things on the basis of that data. So, but it would require the past legacy data. So on the basis of that, it will be automate. It will be predict the things, and it will also give you the percentage of positive response, like 90% of chance of these predictions, 95% of chance for these predictions, like that, on the basis of the data only. So like I have given you the example of the IICT as well. It will also uses this technologies, and with the help of this that IoTs and machine learnings, it will give you the predictions, the tickets probability for confirmations. Okay, and that is uses the machine learnings for predictions. And what IoT device? IoT device generally like a sensors. Okay, I have given the example for the water and Google Homes. Once you are coming to your home, your lights will be automatically on. That is IoT device. Your sensor is detected someone is coming, and it will automatically switch on. That is the IoT device. Then on the it will give you machine learning will be having the algorithm on the basis of data, and that and it will be creating some functions for any task. That functions will be using in the Python or Java, like sensors. For sensors, machine learning will be creating some functions. That function will be using in the Python. So you'll be having some result like that temperature is exceed 200 to some degrees, like 40 degrees temperatures having. Then your tap will be on for the that means the plant will require the water, like that. So machine learning is a part of AGI. So it will communicating with the IoTs. Okay, so it would require to analysis the data. And IoT, what it does, it will collecting the data. It will giving to the machine learning, and it will process on the basis of that data. It will take a decision. It will automate the task. Okay, what else we can do? Like manually, you are just giving the water to the plant, so it will automate that task. Similarly, the robotic processing, it will machine learning automating that task, the same task, repeating task. Okay, so that machine learning will does. Then Java, Python. Java, Python, as I said, Java and Python is a scripting language. Any scripting language we can use. There are many library we can use under Java and Pythons to communicate with IoT. Okay, that technology will be using. And what is the future trends? So future trends, federated learning for decentralized model training. Okay, that would be the future trend for IoTs. TinyML. So right now, the machine learning is scripting, machine learning, whatever scripting we are using. So it's quite lengthy. So it would be using some TinyML, then ultra lightweight models for microcontrollers. So that are the future trend for IoT. Like like 5G integration enabling faster edge to cloud communications, self-learning edge systems with adaptive intelligence. So that all are the future trends. Anyone having any more example for the IoT, or anyone having any questions regarding this architecture? Then let me give you one more example. What I thought. So yeah, uh, in many of the places, many of the cities, it is already been operated. So earlier, traffic police is standing every squares, and they are just looking into that who is wearing the who is wearing helmets, and who is breaking the signals as well. Okay, they are looking into it. But nowadays, who is working on that instead of that policeman, instead of that traffic police? Who is working behind that? IoT now. Every squares now they have settled that all the cameras, and camera is connected with that IoTs. And nowadays, once the signal is breaking by anyone, camera just detect their that number. Okay, on the basis of that, the challan will be on the home, right? Nowadays, so it is using with the help of AGI. With the less resources, they are achieving their work in all the sectors they are using right now. So similarly, we can think on it. We can improve our service. We can build something new as well with the help of that IoT. We can work on that machine learning. We can because the data would be required, but we can use it in everywhere. We can automate each and everything with the help of that. So only require the thinking on that, and we can build each and everything with the help of that. Then summary of that, the impact. So AGI brings intelligence closer to the data source, enabling real-time, secure, and efficient operations. Then it transforms IoT ecosystems from the data gathering network into autonomous decision-making systems. Okay, so on the basis of that, the summary is that on the basis of the IoT device, a human can take a decision. What can do? We can automate the things in everywhere. If you are using a car, there is many chips, many sensors is there that is using for the IoT right now. In the agriculture, they are using for the cropping. In outside, they are using these IoT devices. So everywhere that is using the IoT devices. So how IoT devices working with the machine learning? So I just explained that thing. If anyone having any doubts, what is Edge AI? I can explain it once again. If anyone having any doubts related to Edge AI, what is IoT, what is IoT devices, and how machine learning will be implemented into that.
Uh, yes, sir. I have one question. If you
Mhm,
allow me, then I can
mhm.
ask.
Sure, sure.
Sir, basically, we had seen initially there's a terminology AI.
Mhm,
Here we have seen the age AI.
mhm.
So, what
Right.
are the basic differences? How can we differentiate these two terminologies?
Yes.
And
Mhm.
the second question, where the two is going to be applicable in our day-to-day life.
Mhm. Right. So AI is a artificial intelligence. The first thing, artificial intelligence. So AI, AGI is a type of AI. Generative AI is a type of AI. In previous sessions, we had the generative AI. That is a type of AI. So in generative AI, we have the data, and on the basis of we have the result. In AGI, we can use on the basis of some devices. Artificial intelligence, that is some intelligence we are applicable, we are applying some intelligence, and on the basis of we are taking the decision, or machine is taking the decision. Okay, so machine learning is giving you the result, the dashboard, on the basis of the data, the past data or current data. Like sensors giving us the data. On the basis of machine learning, applies that thing. Yeah, we have this data, and what we can do on the basis of some conditions, like temperatures, or anything, any basis of some conditions, it will be applying in that device. So AGI nothing but it's a type of AI, and it is integrated with the machine learning, with IoT. IoT is a device, and machine learning is IoT is giving you the data, and machine learning applying the different patterns, for the positive pattern, negative pattern. On the basis of that, we can decide what we can do.
Okay, okay, thank you, sir. So that's why I ask this question.
Mhm.
Means, in layman, if someone is going to ask this question, how we can
Exactly,
differentiate this as AI
exactly.
between AI. So,
Right,
uh,
right.
what basic terminology we should
Mhm.
uh, include while
Right,
explaining these two terminology?
right, right. So AI basically that is a intelligence. It's taking a intelligence, right? So that's why we have the generative AI, we have the AGI. Okay, so everywhere we are using that one. So that is a taking of one intelligence. So on the basis of that intelligence, machine intelligence, it is giving us a result. So where the machine is taking the decision, on the basis of that, so there is using the AGI, there is using the AI. So similar way, AGI is a type of AI, and it is integrated with the machine learning with some device, because it is giving us some result on the basis of some data. It is taking an intelligence on that instead of
Okay,
human.
okay, thank you, sir. That means we are going to take the advantages of artificial intelligence in any
Yes,
mechanical device with the help of IoT.
definitely, definitely, definitely,
Okay,
we can do that.
thank you, sir.
Anyone else having any questions?
Good evening, sir.
Good evening.
Sir, I want to know more about the tiny ML and its application area.
Okay, that mean you want that machine learning
Future.
and Java something.
No, no, no. Future of AGI.
Okay, for future,
Yeah.
it is working like that mean the team, or I that the different companies as well. They are,
In the slide, you write the second point.
yeah,
Yeah.
here, right?
Tiny ML. Alter.
10 years.
Yes, yes. Yes.
Yes.
Second
So
point, sir.
right. Yeah, second point. So 10 ML, that mean machine learning right now is machine learning is very vast right now. Okay, it is collecting the data, then many algorithms, and nowadays Python is quite easy, because many functions is built on the machine learning. Okay,
Yeah.
so behind any functions, we are writing some code in the machine learning, and it will creating some functions. Okay, so we can just use the functions in the Python, and it will give a result. But earlier, we were writing so many of scripting, like 10 line, 15 line of code earlier in the Python itself. Then you'll getting some result. But nowadays, in a single line of code, we can get a result. with the help of that machine learning functions. Machine learning. So machine learning is writing some script behind the function, and that function we can use it. And similar
Okay.
with the, in the machine learning as well. So it's a huge algorithms we are using. So in future, the tiny ML, that mean we'll be using some light thing. Okay, we'll be having some more uh, ad hoc thing what we can use in machine learning. So it would be the compressed one. So we can again, it would be, I think, time saving in future with the help of tiny ML. So ultra lightweight model, that is because right now whatever the sensors is working, so behind that we have whatever model we are using in the machine learning, that is a huge right now. We can say that this IoT is working, but behind that is so many of code, so many of algorithms we are using behind that. So the future is that it would be very tiny and the lightweight model.
Okay, sir. Thank you.
Welcome. Anyone else? Any questions? So now I think everyone having a bit idea about what is machine learning and how it works. Because if you never heard, then definitely we were something down because we don't know about what is machine learning, how it is working with that. But if you will be having idea, you can think about it. You can definitely think ahead for the AI. And you, in daily life also, I'll just encourage you to use it. Like if you are using the Excel, just try to use the Microsoft Copilot project. Okay, you can use some more thing. If you are using Excel, you are using Microsoft Office. Okay, you are writing your mails. So you just in daily practice, I'll just say, just use the AI.
Okay, any other queries from the participants?
One general question, if you allow me, then I can
Yeah,
ask.
sure.
Because since all we are academicians and we are moving and we are giving more priority to these things, AI and generative AI
Hmm.
and its application in our day-to-day life.
Right.
So means how in future how it is going to be more beneficial and or it will deteriorate some capability of human also.
Mhm.
So means what kind of limitation is there and
Mhm.
how much we should use in our day-to-day life? Is there any
Mhm.
limitations or if you suggest then we can use it for the
Yeah,
betterment only, not
yeah, definitely. For IoTs, basically, we can use that mean in day-to-day life. Uh, if I said the AGI, so AGI basically for the improving our services. Okay, like for as right now we are for agriculture sector, as I said. Okay, that is using the IoTs devices. And in day-to-day life, we can say for security purpose, you can see uh, we have the door, like the fingerprint sensors, right? That is for the security. Right now, you know the theft can be broke the lock as well till now. But if you are applying some security for the door, like IoT, if you are applicable, so it would be giving the more security. It will be only open with the finger sensors. It will be open with the your some pin code. Your door will be open. So in day-to-day life, we can use it, that IoT as well. But yeah, right now it's using in the big sectors. But yeah, in now in coming days, definitely many things, many equipment will be embedded with the IoTs.
Yeah, thank you, sir. I think means there should be some the balance because nowadays we are seeing observing some student and asking for CV. They are
Mhm.
generating their CV with the help of AI
Exactly.
complete, and they don't know what kind of word they have
Mhm.
included in the CV.
Right, right, right.
Once we are asking them, you have mentioned this, they suddenly they astonished and they are unable to
Mhm.
reply.
Right,
So
right.
means I think we should have some means balanced application of AI in our life also, as you
Exactly.
suggested for office, for
Mhm.
Excel. If we
Right.
are totally rely on that, I think
Mhm.
we will be paralyzed, some partially paralyzed in that direction.
Exactly, exactly. Yeah. So there is some advantage and disadvantage as well. As you know, earlier we were some work as well, but nowadays once the AI is having, then no one is thinking, right?
Mm,
They are
mm,
just getting the answer from that with the help of that generative AI.
mm,
So yeah, that is a disadvantage, but
mm.
the human place is taken by AI in future.
Yeah, thank you. But that means we have to take care of these things also. Means
Exactly,
balance application. I think that will be more helpful for us.
exactly, exactly.
Thank you so much, sir. You have given very nice presentation. Thank you, sir.
Thank you, sir.
Okay, thank you, sir.
Sir,
Okay, okay.
since you belong to industry, I would like to ask you a question.
Yeah.
As we were talking of the cloud and like all the data storage
Mhm,
entities,
mhm,
I just want to know that being an electrical engineer, sometimes it bothers me that how much energy consumption like GPUs and
mhm,
APUs all do.
mhm.
So, like it is all adding up to like the global warming, right? Because
Yeah.
if I take a NVIDIA card, like for
Mhm,
the processing,
mhm,
it consumes around 1 kilowatt of power roughly. So,
mhm.
what is your perspective on this?
Yeah, on the basis of that, if you are using that many, you are just taking a good example. That is, I appreciate you. So, yeah, so on the basis of that as well, uh, in the IoT, it will work and with a less, I think, what you said for the electrical engineering as well. So we can use that IoT as well. We can think about it actually.
Okay.
Any other question?
Thank you, sir.
Thank you.
Okay, thank you, sir, for your insightful and thought-provoking session. Your talk on Edge AI, integrating the machine learning with the IoT, has given us a clear understanding of how intelligent edge computing is transforming the modern digital and industrial landscape.
Yeah.
We truly appreciate the time and effort you took to share your valuable knowledge and experience with us, sir. On behalf of the organizing committee and all participants, we express our heartfelt gratitude to you, sir, and hoping to have much more such insightful interactions with
Sure,
you in
sure.
the future. Thank you so much, sir, for giving me valuable time.
Thank you, Swati ma'am. Thanks everyone for being these sessions too good as well. Thank you so much. Thanks everyone.
Yes, sir. Thank you, sir. Thank you. Okay, participants, we will have our next session at 7:30 sharp, 7:30 p.m. sharp for our session 10 and last session of our today. On the topic AI in robotics and smart manufacturing, and our expert, Mr. Jayesh Pillai, will be with us at 7:30 p.m. sharp. So let's have a break of 10 minutes and then we will meet again at 7:30 p.m. Thank you. Yes, I'm sharing the feedback link in the chat box and in the WhatsApp group. Okay, I have shared in the chat box and I'm also sharing it in the WhatsApp group. Okay, so it's 7:20. We will meet sharp after 10 minutes now for our next session. Thank you, everyone. Okay, if the link is not working in the chat box, I have also shared in the WhatsApp group, ma'am. For some of them in the chat box, it's working. For some, it's not working. So there is some issue. So I have also shared in the chat box, ma'am. Yes, ma'am. I have shared in the WhatsApp group also. Vijay, ma'am, I have also shared in the WhatsApp group. I think it's working in the WhatsApp. Yeah, for some of them in the chat box, the link is working. For a few, it's not working. So I've shared in both the mediums, in the chat box and in the WhatsApp group. So you can fill from anywhere. Okay. So let's take a break of 10 minutes and we will meet at 7:30 p.m. for our next schedule, next session. Thank you, everyone. So welcome back, everyone. Our next expert, Mr. Jayesh Pillai sir, has joined with us. So it's time to proceed to our next session, second session of our today. Um, I'm privileged. It's my honor to introduce our expert speaker for current session, Mr. Jayesh Pillai sir, a gazetted officer at Ordnance Factory Ambajhar, Nagpur, under the Ministry of Defense. He is currently posted at Nagpur, Maharashtra, and who has over 10 years of professional experience. In his organization, Mr. Pillai plays a crucial role in the manufacturing and inspection of components for the Indian Armed Forces. His key responsibilities include overseeing round the clock manufacturing of lightweight aluminum bridges, ensuring the stringent inspection standards and the timely delivery within the specified schedules. Today, Mr. Pillai will be speaking on a very relevant and futuristic topic, AI in robotics and smart manufacturing, and his session will help us show to understand how the artificial intelligence is transforming the industrial automation and the smart manufacturing processes through the robotics, through intelligent systems and data-driven decision making. So, on the behalf of organizing committee and Sri Shankaracharya Technical Campus, I extend a warm welcome to you, sir, and we look forward for an informative, engaging, and inspiring session. So, once again, welcome, sir.
Thank you, ma'am.
Welcome
Thank you so
in
much.
our FDP.
Thank you. Good evening, everyone. As ma'am told, I myself, Jayesh Pillai. Before starting our topic for the today, I would like to introduce myself so that we can get familiar.
Yes.
I did my engineering in mechanical in 2009 from Chhattisgarh itself. After that, I completed my MTech in thermal engineering. I was teaching in Rumta Engineering College for 2 years from 2010 to 2012. And after that, I have joined organization Ordnance Factory Board, which the main purpose of this organization is to manufacture components for Indian Armed Forces. Our main consignees are Indian Army, Indian Air Force, Indian Navy. So the main problem we are facing is that how to get the components passed. They have very stringent inspection processes involved. So we have to stick very precisely to all the specifications and drawings which are provided by them. Even though we know that we can make some betterment in those parts, in those components, but we can't do that from our end. So that's the problem we are facing. So basically, I am also one amongst you. Once upon a time, I was also attending these faculty development programs myself. So I have been on that side of the table also, and I am thankful that team of Shankara allowed me to share my experiences with you. I won't be doing any superficial examples. I will be telling you each and every practical example, how minute, how smaller it is, how ground level, how on shop floor we are facing it, and what are the problems we are facing in day-to-day life. Here we are all gathered here. Many amongst us are very highly technically qualified, but we have to get transformed, change along with time. Previously there were time that just being technically sound you can make everything possible, but now that is not possible. It is a transformation phase. We have to change ourselves according with the time. So these the topic which has been allotted to me, that is artificial intelligence, robotics, smart manufacturing. Without knowing this only core technical knowledge won't help us compete with the market worldwide. So it is very important for us, beside knowing our core technical knowledges in depth, we have to gain the knowledge of artificial intelligence and smart manufacturing to compete with the world. So I would like to proceed with, I have made a little presentation. So we will continue with the slides, and along with the slides, anywhere, if I get a chance, I will share with you all the real life experience. One limitation is with me is that being from Ministry of Defense Department, I am not allowed to share real time photos, pictures or videos of shop floor. I hope you all will understand that and
Yes, sir.
help with me. So I'll try my best to explain you what problems we are facing on shop floor today itself. Okay, let's start with the presentation.
Yes, sir.
Okay, can we start?
Yes, sir.
Or
Yes,
should we
sir.
wait for more? Okay, let's start with the topic. So,
Yeah.
as our topic suggests, artificial intelligence in robotics and smart manufacturing. Let's start with the very basic thing with the manufacturing processes. The manufacturing processes which we used to learn in schools, in colleges, that are very core, that won't be changed with any upcoming advancement technologies. We have to stick to those core fundamentals. But what we can do is that the knowledge which we are interpreting into the processes by ourselves, we are trying our best to interpret our knowledge to the machines, to the or the interface which we are processing through. Now let's proceed further. The things which we will be proceeding with is evolution from traditional to smart manufacturing. The traditional conventional methods which our previous counterparts were using, what we have to change to make it a smart efficient one, because previously what happened is, for armed forces, only our OFB, Ordnance Factory Board, were allowed to make components for them. But as the FDI increases couple of years ago, now the private counterparts also involved in the manufacturing of defense components. You have seen that Mahindra Defense, Reliance Defense, and many other defense companies have started manufacturing defense components for our defense units. So it is the responsibility, being a government organization, we are bounded by many policies, but still we have to compete with the private market. So it's a difficult thing for us, but what we can do the least is that we should adapt all the technology, all the advancement which is going in the market, to cope up with the market solutions. Okay, so let's go one by one and I'll tell you each and everything which we are facing in our shop floor. So first one is evolution from traditional to smart manufacturing. The unit in which I am working, basically here we are manufacturing aluminum components, steel components. Here we are doing forging, extrusion components, and welding work. Okay, so these are the traditional work which we are using since past years. Now we have to convert it into a smart manufacturing processes. Now how are we doing that? We are trying to convert as many conventional methods, conventional machines, conventional processes, to convert into CNC machines, to AutoCAD programming, so that our programs, our components should be manufactured under precision work. Okay, so role of AI and robotics also increases here. Here we are working under forging products. In forging products, the temperature of the shells or the products which we are dealing with are very high. It is very next to impossible to work for 8 hours shift, 10 hours shift in that hot condition. So it is very important for us to make arrangements for robotic arms or robotic machines for handling of the components. In real world industrial cases, that's what I was saying, that I will share the all the experiences. It's not just that we are facing problem in manufacturing. There is a problem in procurement also, in inspection also. In all these areas we need smart manufacturing. Manufacturing is not just limited to the scope that we manufacture the components and the process ends up there. After a component is manufactured, it is our duty to check all the control points, all the precision points, all the specifications. Are we following that while transitioning to this AI tools? Okay, so the challenges and future opportunities, the challenges which we'll be facing and which we are still facing, We will see that in future slides, and the opportunities which we are having because of this AI, that will also be dealing with it. Okay. So introduction to smart manufacturing. Integration of advanced digital technologies, AI, IoT, cloud, big data, robotics into manufacturing system. We all are using these technologies in our day-to-day life, in spite of other than our manufacturing, except manufacturing also. Manufacturing is a very huge term, but we are using these technologies in our day-to-day life also. So creation of connected, data-driven and self-optimizing production environment. Actually, what happens when we manufacture a component, when we manufacture a product is not comprising of only one or two types of product. The component which I am dealing, the bridge component, that bridge components is comprising of wooden elements, metal elements, aluminum products, steel products, rubber items. So it is having a wide variety of types of material which we have to deal with. If I have a one particular type of manufacturing line, it is not possible that if I have improvised the machining line of aluminum products, that the same process will be applicable to all the different materials. We have to work on different area for different type of materials, for different type of what do you say, precision, how much precision is required in what kind of work, what is a load bearing capacity components, where load is not applied. So how to which component to be taken care of, and which component can be ignored while changing from conventional manufacturing method to AI manufacturing method, smart manufacturing method. So it will be a very hectic process to change each and every process which we are working since past many years. What happens actually is that any product we are dealing with is actually manufactured with the help of gauges or jigs and fixtures which are manufactured years ago, or which are get calibrated on periodical basis of time. But when we want to manufacture it on the some SPMV, as we used to say, special purpose machine, in special purpose machine, what we do is we feed the program as our requirements. And when the component is manufactured, after that it has to be cross checked, that is it at par with the components which we used to manufacture with our conventional methods. So it is a very huge task to incorporate AI or incorporate smart manufacturing in each and every type of components we are dealing with. So first, our basic problem is that first we have to cater that which component first is to be converted into the smart manufacturing unit. Now, how we will take that decision? We will take that decision by considering that after applying smart manufacturing process, what will be the differences? Will it be reducing my cost? Will it be reducing my manufacturing time? Will it be increasing my accuracy, precision? So based on that information, we have to first we have to select which kind of components we can convert into smart manufacturing. So it is not just one assembly line that you change one or two machines and your whole process will be converted into a smart manufacturing unit. In one single component, you have more than 10 to 20 operations based on the complexity of the product. So what we do is, smart manufacturing means we have to bifurcate each process. Suppose drilling is there, so in drilling operation also we have to first go with the pilot hole drilling, then we'll go with the some counter boring. So that in that way we have to proceed. Now while converting into smart manufacturing, we have to deal that out of these processes involved in one particular component which is not that important, so we can't go for smart manufacturing of such parts. So this is a very crucial part to first decide that out of the 100 processes and number of processes that you are going through in shop floor, which process is to be converted into a smart manufacturing process, which in turn will give you a better output in the end. Okay, so creation of connected, data driven, self optimizing production environment enables real time monitoring, predictive decision making and adaptive control. what this says is that enables real-time monitoring, predictive decision making, and adaptive control. What we are doing these days are, we have introduced one Wi-Fi enabled measuring devices. So that is also helping us in measurement in real-time monitoring. I don't have, or we don't have to manufacture, go on the shop floor to measure each and every component getting measured. The components which are getting out of the final line, that is being measured by a Wi-Fi enabled measuring devices, and the readings that are being noted on the Wi-Fi on the shop floor, we can read it at the our screens on the office. In the office, we are having our discussion. So what this helps us in taking the decisions, that if the particular item is getting deviated in particular this dimension, so we can take the uh, decision at that moment that this particular operation should be changed or stopped, or some modifications is needed. So we don't have to wait for the another bunch of products to get rejected or wasted. We can take that decision on the spot. Okay. So transform traditional factories into cyber physical system. This is what I was talking about, transforming traditional factories into cyber physical system. It is not some very small task. We have to go from very minute processes involved in each and every process, and then we can say that okay, the whole unit or the whole line or the whole shop floor, whole process was converted into a cyber physical system. We have to work very, very deeply on each of the parts which we have to work. Suppose we have a process schedule with which we proceed. So the process schedule which we are following, we have to incorporate each and everything in the smart manufacturing processes, whatever we are using. If we are using a robotic arm, so the program which we have to feed in it, so that program should incorporate each and every process, each and every checkpoints which we used to do in our conventional method. Okay. Now the goal is very clear. We need greater efficiency, we need flexibility, we need better quality, we need sustainability. Without that, it is very vague to go with a smart manufacturing. If we are not having any benefits, as I just said, it is not useful to convert it into a smart manufacturing. If we are converting it from conventional method to a new one, so there should be some advancement, there should be some benefit from it. That will be helping us. Okay. Foundation of Industry 4.0 and future autonomous factories. So as we all know that after the independence, our industrialization has been changing rapidly. We are going through industrialization. Suppose it's going now it's going on Industry 4.0. Many of us have also heard about Industry 5.0. It is the industrial revolution which has been changed from time to time. We are going from 4 to 5 now. The transformation were from conventional method to simpler advancements, and that's what happened in the industrial 1.0, 2.0, 3.0, and 4.0. Now, evolution of robotics in manufacturing. From mechanical automation to intelligent robots, we have seen that first there were as it's shown in the figure step 1, that there was a very nominal kind of robots which is having some very rare movements or work to be done. But now the robots which we are having in today's date, that is more efficient, much efficient. Previously there were the working where robotics or the robotic arm we are using, that is just we put the coordinates and that is without any information. It is just moving from X position to Y position. But now it's not like that. We are using industrial robots in many of the forging plants, in extrusion plants, where we are handling hot products, where we are handling heavy projects. So suppose one is the case where we are having our robotic arm we are using, that we forge products, we forge aluminum billets and steel billets. So what happens that while forging, it is a hot forging condition, it is a red hot metal kind. So what happens is the robotic arm that we are using, it senses the weight of the forged product. If the weight of the product is found lesser than the required condition, it will be kept separately. If the forged weight of the forged condition is found higher than the permissible, then it will be kept separately. So we don't have to segregate the products by measuring each and every weight. I am just talking about the weight category for now. So this is the example that these robotic arms or robotic units, how it helps us segregating and helping us in curtailing our work process in a very short period of time. Okay. Generations of industrial robots. What happens is the core principle behind these robots are almost same, but what happens that each and every organization, each and every shop floor is having different requirements. So based on the requirements, how efficient that particular group which is working on that project is, how efficient robot is he providing for that particular work, that depends on the efficiency or accuracy of the products that we are asking for. Okay, so collaborative robots, collaborative robots and flexible automations, all these works for betterment of the products. So these are the few concepts that we are using in AI. Machine learning enables robots to learn from data, improving their performance over time through algorithms, through recognized patterns, and make informed decisions based on experience. So as I was speaking just now, that as we are calculating the dimensions which we are manufacturing in our shop floor, based on the past records, based on the past data which we are getting, we take the decision that how or which process should be changed, amended. So by involving machine learning in the, or AI, artificial intelligence in our components which we are using for manufacturing, so that itself helps in recognizing the pattern and give us signals that how to change or which processes to be changed or needs to be amended. Okay, next is computer vision. Computer vision allows robots to interpret and understand visual information from the world, enabling tasks such as object recognition, navigation, interaction with their environment. We are using itself in our day-to-day life. So that is a one thing. And NLP, natural language processing facilitates communication between humans and robots, allowing voice commands, text inputs to be understood, enhancing user experience and interface interaction efficiency. This is something I haven't seen yet in our industry. It might be happening in some high-tech manufacturing units. In our industry, I haven't seen that any of the that voice command should be taken for any machining unit for taking the command. So we are not using it for now. AI fundamentals. Now, understanding the AI roles in robotics. Traditional robotics relies on pre-programmed responses. As I before, we used to many of us have read that we used to read and make the program by G codes, M codes by for our CNC machines. So these are the traditional robotics relies on pre-programmed responses, while AI powered robotics uses data-driven algorithms to enhance flexibility and adaptability in dynamic environments. Okay. AI-powered robotics utilizes machine learning, computer vision, allows robots to learn from experience and make autonomous decisions based on real-time data analysis. Okay. Learning and adaptation. AI enables robots to continuously learn from the surroundings, adapt to new tasks, and improve performance through interactive feedback, enhancing overall operation efficiency and effectiveness. If we see, these are all the works that we used to do. We as a engineer, or we as a manufacturer of the components, we have to do that. But what we have done is, by the process of AI, we are shifting this our work to the the real intelligence which some human being is incorporating in the process, that we are trying to do with the AI. So again, this is the technologies that we are using: machine learning, computer vision, natural and language processing. Now again, AI plus robotics is a powerful pair, as we know that without robotics nowadays it is very difficult to work in each and every unit. I think where a mass production is going on, robotic unit is a very important one. So we have to go through it. Now I should tell you some examples that where we are using it. Suppose I am manufacturing one profile, okay, extruded profile. So as we all know technically that there are many processes of extrusion, extrusion, indirect extrusion. So what happens is, suppose my requirement is the extruded product should be as thin as 2 mm, 3 mm, and the length which I require is more than 5 meters, 6 meters. So what happens is, when we go through the extrusion process and the dies and punch we use, so for that particular thickness which I just mentioned and the length, it is very impossible to extrude the product in such higher length with such smaller thickness. So this is one just a small example that what problems we are facing. So what we can do now, so our capacity of extrusion press might be low or might be outdated, so it is not able to process the particular kind of products. So what we do is we search for the vendor who can provide us with the such specification of products by using the same technological method. By using the extrusion, the grain flow direction must be same. So what we should do now, AI enables perception, reasoning, learning in robots. Okay, so we have searched one vendor, we should go for manufacturing with that. We allow them to provide us with the product that you can manufacture, but it is not possible for us to each and every time go for inspection and go for checking of the process schedule, that how they are manufacturing, are they involving all the process, all the checkpoints while manufacturing, which we used to check here. So in that time, what happens is this AI helps us a lot. We can in real time data we can collect from them, that after the manufacturing or during manufacturing processes, all the control data, all the control points we can have on our screen from their end. We don't have to be physically present there. So that is one of the best example that AI and robotics, we are working together, which is giving our work on our fingertips, that we don't have to move from our places, and we can from there also we can take our decision that this process should be proceed further or it can be held on. Industry 4.0 framework, digital transformation in manufacturing. We are collecting each and every data. Previously we used to collect and record each and every data manually, so it is very difficult to collect and interpret decisions from the manual data. Now what happens is, all the records, all the data, all the tolerances, all are being recorded in the digital form. Now from there we can easily interpret that what decision has to be taken, or we can proceed with the same manufacturing processes involved. Okay, core pillars again: AI, IoT, cloud, big data, and robotics. So these are the things I won't be discussing. I will be manually focusing on manufacturing side. Digital twin and smart factory concepts. Now what is this digital twin and smart factory concepts? Actually what happens is, suppose I am manufacturing one component whose weight is more than 100 kgs. So when I want the raw material for the particular components, or the profile or raw material profiles, or some extruded components, if I require, it is not possible for me or us to move from one place to another. So what we do is, we ask for a digital twin of same size, same shape, for a much cheaper product or a much cheaper material, which we can have our test, so that it will give us a temporary idea that will it be feasible to work on main components with original material which we are going through. Okay, these are some of the architecture of smart manufacturing system: data layers, processing layers, control layers, and decision layers. Okay, now these are human robot interaction, voice based interfaces, and chatbots for industrial robots. As I said, I haven't been introduced with such technology yet. It might be working somewhere. Cognitive assistance in manufacturing lines, improving safety and usability through language understanding. This is one of the major portion which we work on industrial lines. Safety is one of the major concern. So what we do is, in spite of having a very sound manufacturing line, we have also required to uh, concentrate on our safety of as we know that man, machines and material, safety of all these portion is very important. We can't afford loss of a human, we can't afford loss of a costly imported material, we can't afford the loss of machine tooling parts of any special purpose machines. So it is very important for us to side by side also consider safety to be one of the major aspect while incorporating smart manufacturing. It is not like that you are reducing the time, you are reducing the cost at the cost of material or at the cost of safety of the workers working in that environment. Reinforcement learning applications. Now, as we all know that robot learns by trial and feedback with what feedback we are input we are feeding based on the past data, optimizing motion and energy use. Examples of autonomous robotic arm optimization, as I've told that robotic arms we are using for shell distribution after the forging. Robotics and smart manufacturing. Industrial robots, automated guided vehicles, AMRs, collaborative bots. These are some of the robotic units which we are using for our smart manufacturing. Robots in logistics, weldings, inspections. Very simple. We are following very lots of processes for our logistics, for our welding inspections. What happens is that when we are welding aluminum or steel welding, so it might be possible that the welding defects or the welding cracks which we learn in our theoretical classes and during UG classes. So what happens is we are facing is that we need to, being manufacturing bridge item, the components which I am manufacturing should be floating one. It should not get sink into the water. So when we are manufacturing the components using welding or riveting, so the welding components should be leak proof. Now it is very difficult to visualize the cracks or the welding defects from the naked eyes. So you should involve the welding trial. So what we do is we perform a leak proof test of all the welding components which we are manufacturing. For that, what we do is we apply a soap solution on all the welding beads, and we give the high pressure air from a dent into the from a hole, air pressure hole, to the compartment which needs to be floated. And then we check if there is some air bubble coming outside from the welding bead. If the air bubbles is coming, in spite there is not any visible crack or defects which we can see from our eyes, but there should be some defects, so we have to remove that. And after that also doesn't finish our welding inspection. We have to also inspect it by keeping it in the water for more than 3 to 4 hours to check if there is any welding leakage. If there is any welding leakage, that component has to be go for rectification. That can't be go further for further inspection or further manufacturing processes involved in that. So these are something in which robots can help us with inspection process that is involved in welding and other manufacturing processes also. Okay, integration with AI and IoT systems, we are using it in each and every day-to-day life. It is not just used in the manufacturing, it is also used in inspection of the component. It is also used in while procurement, the testing of the raw materials at that stage, by checking the parameters of final products. It is involved everywhere. Use cases are assembling, packaging, and inspection logistics. Collaborative robots work safely beside humans. AI-based safety and task sharing. So if a group of person working together, there might be some miscommunication or mishandling of the products, which can which can be the cause of accident for any one of them or both of them, or people involved working there. So collaborative robots, the work environment which is very risky, which is not safe, which is not in safe condition, where we can use collaborative robots for our processing. Now, till now, we were only talking about the manufacturing and the inspection perspective. It is very important that our life of our machines, or the robotic arms, or the units, AI units we are using for the manufacturing or inspection units, should be maintained properly. So basically, some few 2 to 3 types of maintenance are there: regular maintenance, predictive maintenance. So what we do with predictive maintenance using AI is the data from sensors and machine logs. Now these days, all the CNC machines, lathe machines are special purpose machines which we are using. They are oversensitive. They will give you message beforehand that coolant is low, that the air pressure is low, the filter is not working. So all the message you can get on the interface. So that helps us in predictive maintenance of our component. We don't have to work till the last moment that our machine will get stopped, our shop floor, our production line will get stopped. That condition will never happen, just because of this AI interface which we are having on the screen of the panel of our machines. Okay, so data from the sensors and machine logs predicting failures before downtime, which is very, very helpful for us, even for hours or for few shifts. If one particular machine is down, it will affect the whole shop floor, because all the components are dependent one after another. So it is very helpful for us in maintenance also. So apart from, as we were talking, manufacturing, inspection, procurement, it also helps us in the maintenance of the components, machine parts, toolings, that your the pressure inserted, pressure on the tool or tooling which we are using is getting increased. So that in that case also, we take the decision of changing the inserts that we are using. That helps us in increasing our tool life. Okay. Tools that used in predictive maintenance using AI are that machine learning models, anomaly detections, vibration analysis. These are the things which helps the AI interface to report the error to the user or to the operator. Digital twin technology, one of the best example of digital twin technology which we are using is that virtual replica of physical system, that real-time simulation of manufacturing system. The component which I required, that should be manufactured in some what should I say, artificial material, or some comparatively cheaper material, so that we can compare the defects which we can face in the original products without involving the costlier items which we are manufacturing. Supply chain optimization, AI for demand for forecasting. It is very simple now. If you are working in any particular field, you can, after working a few particular years or few particular seasons, few particular time, what you yourself can demand forecasting, that whoever your consignee is, whoever your customers are. So we ourselves, from our end, we can forecast the demands which is fluctuating from throughout the year, throughout the particular time of the year. So that is what now they are dealing with the help of AI. Robotics in warehouse automation, real-time inventory tracking and decision making. These are all helping us in maintaining our store. Now in our department, what we do is we having 3 types of stores. It is not that store is something that is helping us keeping the material in one place and dispatching to the shop floor. There are a lot more things involved in the store sections, and using of AI in the store section will also be very helpful for us. Suppose what happens is, any material that is coming inside the industry, that will comes in one particular store. All the incoming material will come in the incoming store. After that, the incoming material that is came from outside vendors will go through a harsh inspection process. After inspection, the components which got selected, which got okay, satisfactory, that will go into the store stock department. The rest components will be get rejected and go outside the factory or the industry from which vendor it has been supplied. So these are the two stores till now which we have seen: the incoming stores, the store stock where the satisfactory product is kept. After that, from those stores, the product is being shifted to the shop floors, various shop floors, extrusion shop or manufacturing shop, welding shop, drilling shop, milling shop. So that after manufacturing, the final product is kept at the third kind of store, where the components or stores are kept for issuing to the consignees. So these are the kind of stores. It is not possible that under one roof you can keep all the kind of materials, the incoming materials, the materials which are in process manufacturing, and the materials which are finally completed and is ready to issue. So these are the bifurcations we use in our industry for handling of material. So it helps us that for segregating, if we want some chemical products, there should be some different stores. There should be one particular bin card system which we used in our conventional method is now being automated, and on the click of the finger we can just know the amount, quantity, the requirement, the how when the last consignment has been placed, what was the rate of the last consignment, which vendor has been placed that, and what are the current rates. These are the data which we can get from our store departments within few seconds, and this is all possible because of the artificial intelligence and automation that we are incorporating from time to time. Autonomous mobile robots, self-navigating using simulation, localization, and mapping, AI for obstacle detection, real-world application in smart factories. So these are the things which we used to incorporate in our shop floor, without which it is very difficult to handle a huge manufacturing line for any kind of industry. We are dealing with more than 20 to 30 major components, major stores of consignees are consignees. So it won't be possible to go for particular any conventional method for such a huge production line. Data analytics and AI integration, collecting, cleaning, and labeling industrial data. So this is what we used to do in our conventional method, which in our any local shop floor, which we used to see in our industrial areas in each and every city of India. So they are collecting, cleaning, and labeling industrial data. This is we are using with the help of AI integration. Okay, all the things are being automated, and which helps us in taking future decisions for our manufacturing. Real-time dashboards and key performance indexes are something which we record from time to time. Feedback loops for continuous improvement. Now, cyber security in smart manufacturing. We are talking about incorporating AI and robotics in all the manufacturing processes which we are working with. But there are also some security point of view which we need to think on. That what happens is, if being not a public component, being not a public product, each and every product and each and every drawings which we are dealing with is not a public entity. We can't share it with any vendors, any customer who is ensuring us that yes, we can supply it. We have to make it very much sure. We have to take undertaking that you will not be going to share any of these confidential data, drawings, specifications, materials to any other vendors or anywhere outside. So as it is in my case, it might be in many industries that their products or their USP is there. They can't share their personal data with other marketplace. So we have to manage that also, along with the incorporation of smart manufacturing, cyber security in smart manufacturing, AI for threat detection and anomaly monitoring. We are using intranets, we are using internet system in almost all the units. So there is a threat of breaching of your data, so you have to protect your data. That is very important for us. Protecting IoT and robotic systems, the programs which we are incorporating, the advancement or the improvement that we are involving in our processes should not be compromised with. Risk of data manipulation, as if it gets the if it gets in hands of the some inappropriate entity, it will be manipulating the data, and the whole product line, whole shop floor line will be get rejected due to that. So this cyber security in smart manufacturing also very key point to be look after. Now, key benefits of AI in manufacturing. As we discussed earlier, without any benefit, it is impossible to convert from conventional methods to the smart manufacturing method. So there must be a huge benefit to the products, to the society, to the output of the products, to the manufacturing system, so that these smart manufacturing units should be incorporated. Increased efficiency, cost reduction, enhanced quality. Now, the most important one amongst these is enhanced quality first of all, because customer of each and ours are looking for the best of the products. They are not binded by that we have to buy our products from this particular unit only. So the first and foremost thing which we have to focus on is that our quality should not be compromised. It should be get enhanced. That will be on our better end. Okay, now just by enhancing the quality and you increase the rate of the manufacturing cost by 10 times, 20 times, then you are nowhere in the market. So you have to go parallelly. You have to increase the quality of the product. You have to increase the shelf life of the product which we are providing to the customers. You should provide after delivery services to the consignment of the consignment, and parallelly to this, you have also to maintain the cost, because if you are not maintaining the competitive cost with the other players of working on the same field, then it is of no use. Okay, the best thing which we can do is by increasing the efficiency, by increasing the productivity, that within the minimum least, by incorporating the least time, by incorporating the least manpower and least wastage of material, how we can manufacture the best kind of components which we should be doing for our consignees. Now, flexibility and scaling, enhancing production efficiency with AI integration. AI technology enables greater flexibility and scalability in manufacturing processes, allowing businesses to adapt quickly to market changes and efficiently manage varying production demands. Now, what happens is, if I am manufacturing some components, it has been going to our consignment. So what happens with the defense products is the components which we are manufacturing, or the bridges items, or the any kind of shells or any defense products which we know, that has been sent to depot, and from depot it has been sent to training units. In training units, the components are being dummy or having the same dimensions, but are not filled with explosives or the any destructible material. So they are using it for the training purpose. Now, while training, the person who are involved in the training, or the person who are coming for the inspection process, they give us regular feedback that the component, that this particular component that you are manufacturing, we are facing this particular problem in while using that, while using or while training, it is heavy, or it is difficult to handle, or it is getting damaged very easily. So these are the feedbacks which we get real time from our customers, our consignees, and we have to work very sincerely on that. But on the other hand, we are not allowed to get deviated from the blueprint, from the process schedule which we are working on. So it is very difficult for us to automate the process. We can't change the manufacturing. We can't skip the process. We can't amend the product for the betterment of them. In spite, we know that if there is a chance, there is a possibility, we can do that, but we are not allowed to do so. So we have a very strictly, we have to get stick with the process schedule which they are giving us. And same is the condition in inspection process. We know that if we are manufacturing a component, it is not of functional use. If some particular part of some component is not of functional use at that particular end, but still if there is a checkpoint, that we have to maintain that. In spite, we know that it is of no use. So that is something that where we are facing, that this flexibility is not for us working on our components. Workforce transformation, human machine collaboration. Previously, all shop floor means each and every trade person is involved in the manufacturing. Now it is not like that. One CNC machines or the robotic arm, and one operator is handling more than 2 or 3 robotic units from one end. Okay, so what happens is that there is one robotic unit in our section, is that we are forging shells, which we are using in different kind of rockets. For rockets, we are manufacturing shells. So while manufacturing shells, we used to forge it, forging of steel forging and aluminum forging. So it is of various diameter based on the barrel size of the machines through which they are going to use it. So forging is not possible in one draw, so they are using more than number of one draws. So number of draws which they are using, though the robotic arm, the number 3 different units are being involved. First unit is doing the first draw, second robotic unit is doing the second draw, third is final draw. So these are the cobots which we are talking previously. Collaborative robots are working there for complete operations, and one human operator is present there for operating the 3 robotic units there. Okay, upskilling of AI enabled environment, that is what we are doing. We are trying to incorporate AI units as all we are gathered here. We all are working on AI enabled environments in our fields. Role of faculty in developing future ready engineers, that is what we are doing. If we don't get our current engineers, current UG students to get prepared with this transformation, it will be very difficult for us to get into the manufacturing in very conventional method. When we were under undergraduation, we were not studying these terms at those times, but now we know that how important it is and how significantly it is helping our industries. Now, what are the challenges and risks? So there are huge challenges which we have to face while incorporating these some of our cyber securities. Now what we have to do is that one thing everyone is facing is that is not something to be hidden. Every unit, every industry, every institute, organization is having their own budget. It is not that if any particular smart manufacturing or AI involved or robotic arm can give you the best solution. That institute, that particular unit should afford that. There should be a proper balance, because market is very fluctuating. You are not assured that there will be a continuous order for you for the next 10 years, next 20 years, or might be next 1 year, next 2 year, next 10 months. So if you are if you have already judged that yes, this smart manufacturing unit to be incorporated in our unit, then there is also this one challenge and risk that the incorporation of these are the one problem is that high initial cost. So implementing AI systems often requires substantial investments. Obviously, first we have to make our own decisions, that is it beneficial for us. Is my organization is having that much order in our hand that we will cope up with the investment which we are doing on the investment on this implementation of AI. Okay, so implementation AI system often requires substantial investments, making ROI considerations crucial for business exploring automation and innovation opportunities in manufacturing and robotic sectors. So this is one of the major thing that it will be incorporating lots of input, high initial cost. So that is to be considered while considering the smart manufacturing units in the unit or organization you are working with. Data security, as I said, if you are working with the public entity, public components, which is nothing to be keep confidential, then it is fine. But if you are having any kind of data, any kind of USP that you are working on your product, data security is one of the major thing. As AI technologies integrate into the connected systems, data privacy and security become paramount, necessitating robust measures to protect sensitive information from emerging cyber threats. Okay, skilled workforce. First of all, we need people who are very having very core knowledge of their basics of the processes involved. Then we need kind of peoples who are in the transformation, that who are having a little bit knowledge of a conventional side and little bit knowledge of a AI side, who can be a bridge between both the parties. So without all kind of workforce, it is very difficult to transform conventional method into a smart manufacturing process. So these kind of skilled workforce, that is what we are trying to maintain in our unit also, and that's what you are also trying to make our participants, that we should all get all to get to know about the things that we are facing in our industries. So integration complexity, navigating legacy systems into AI implementation. Integrating AI into legacy manufacturing system poses challenges due to outdated infrastructure, requiring careful planning and substantial investment to ensure compatibility and functionality. As we said, that it is very important to take very careful planning, and we are having very outdated infrastructures and conventional methods, machines which are being used, and no problem using it in future. But if you want to improve the efficiency, productivity by reducing your wastage of material, so you have to go for integration with AI. These are some of the future trends that we can see in our futures: AI algorithms, edge computing, AI cobots, additive manufacturing, sustainability. So these are the things which we can see in future. Additive manufacturing is something that previously what we used to do in conventional is that we are having our raw material from which we are reducing the material. We are cutting the material by using milling machines. We are drilling the components, and we are wasting the material by taking it out from the raw material. Now additive manufacturing is something, one of the best example of additive manufacturing is 3D printing, that you are not going to remove any material, you are going to reprint the prototype kind of material of the components that you are requiring. So these are some of the future trends which we can see in AI. Now let's see about role of academia. As we know that we are dealing with the most of the participants here are working with the fresh engineers who are working studying in colleges right now. So we can have research in robotics and AI collaborative projects between academia and industries. We are having one project here right now in Nagpur. One of the professors of VNIT Nagpur, they contacted us that for one particular kind of bridge, they said that if you can share the details, then we can work on it and we can reduce the weight of the components that we are manufacturing. Actually, what happens, the aluminum bridge which we use to manufacture is a dismantling bridge. You can dismantle the bridge, you can assemble the bridge in the location where the whole battalion can't go, and the whole pathway is not very suitable for the battalion to pass. So these bridges can be manufactured, installed there erected there within 2 to 3 hours in daytime, 3 to 4 hours in nighttime. We have also seen recently that few bridges have been erected in past few months, if I am not wrong. So these are the kind of aluminum bridges, steel bridges that we manufacture. So these components are being handled manually by the army personnel. So the major concern is that the weight of the components should be very, very low, so that our personnel can handle it by their hands. And the other side of the product is that load bearing capacity should be very high. The whole battalion, including the tanks and the other heavy trucks and filled with components, should be passed over it. So load bearing capacity is also one of the very important parameter. So these things are to be considered, that we are not going to compromise with the load bearing capacity of the bridge. On the other side, the weight of the components which we are using should be as low as possible, which will help our army personnel to handle them. So one of such project is been going in PNIT. So that is what we can go for. And AI focused engineering curriculum. So if study material or the curriculum which we are teaching the students, it should be AI focused engineering curriculums. It will be helpful in future. Faculty's role in innovation and skill building, curriculum development in AI and robotics, upskilling programs for students. That's what we are going through. So it has to be incorporated, which will be very beneficial for future industries. A brief in cap: AI is transforming robotics and manufacturing with intelligent automation, predictive insights, and human machine collaboration. Okay, AI plus robotics is smart manufacturing. That is what we are going to do. The future is human plus AI collaborations. Now let's explore how faculties can integrate AI and smart manufacturing concepts into teaching and research. Till now, I was discussing about how AI and smart manufacturing concepts are being involved and using in the industries we are working here. So now we can discuss about that, how this can be incorporated in the teaching field, or it should be start from the scratch. If the students which will be coming from in our units or in any units after their completion of the studies, they should have the prior knowledge that what things and how the changing times are to be, the technologies to be incorporated in the unit they are going to work with. So these are some of the things that our teaching units should also be incorporated. As we know that even in villages these days, they have already incorporated that smart TV, smart teaching capabilities have already been installed in villages, in some of the schools, colleges. It should also be incorporated in other units also. So it will be helpful for students. There is one quote on AI that I recently got while preparing for this presentation. The future of manufacturing is not about machines replacing humans, but about machines and humans working together to create smarter solutions. If you are very confident with what you are doing in your day-to-day manufacturing, or in whichever field we should never be, we are not in a stage that we should be fear that these machines or AI will overtake us. There will always be, that's what my personal belief is, that there will, if you are really working on the core, in the depth of the core of in which field you are working, it will be very difficult that we should be worried about the machines, that they will take over our work. So there is always something that we have to give input to them. So it will always be a two-side thing. So it will be better that machine and human and machine interface should work one-on-one together. Thank you everyone for your patience listening. I don't know how helpful I was for all of you, but I tried my best that what industrial experience I was having, I should share with you, and I tried my best for that. Thank you.
Yes, sir. Thank you, sir. Any queries? Any queries from the participants?
Yeah,
Ma'am.
yeah, I
Okay.
am Dr. Uttam Kumarkar from CCT Bhilai, sir. Thank you for a nice presentation. I would like to ask one question, sir.
Yes, sir.
Sir, what are the biggest challenges industry is facing now by integrating this AI and robotics in the existing systems?
So the first thing is that actually what we are doing is we are the manufacturing unit. I will talk about my organization. So what we do is our consignment is, as our consignment is Army, Air Force, and Navy. The inspection authority that we have is CQAE, and Controllerate of Quality Assurance Establishment. They won't allow us to deviate from the manufacturing processes involved. Suppose I am manufacturing one component, they have given me one process schedule. In those process schedule, they have also given me the gauges, the number of particular gauges, that this XY gauge you have to use, this particular jigs you have to use, this particular fixture you have to use, and these are being audited from time to time. So it is very difficult for us. We can by incorporating a huge amount or particular amount of money, we can incorporate smart manufacturing. But in defense industry, it is very difficult to make them convinced that we are skipping your gauges and jigs and fixtures and control points by incorporating smart manufacturing. For our particular case, it is very difficult to convince them for this. So this will happen when they will use one or more number of components manufactured based on smart manufacturing. But we have, or any organization have to take that risk before investing in that area. So that's what the first thing that which is holding us from converting into smart manufacturing, or our manufacturing units we are currently working with.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you so much, sir, for such a nice presentation and insight into the manufacturing process. Like, I would just like to ask you one thing. Like, as I'm into teaching, like I've been recently studying the papers on digital twins. So, as you have talked about this technology, how can we use reinforcement learning and digital twins integrated together to
Ma'am, your voice is not clear. Ma'am, please pardon.
Sir, as you have talked about the digital
Digital
twin
twins. Yes,
system,
ma'am.
right?
Yes, ma'am. Yes,
So
ma'am.
I would like to ask you that how reinforcement learning and digital twins can be integrated together so that we can have a self-optimizing manufacturing robots, as you have talked about the industry 4.0
Yes, ma'am.
ecosystems.
Yes, ma'am. Ma'am, digital twins, we are using digital twins for the components or the raw materials which we can't manufacture at our unit. So that for that purposes we are using digital twins. We are using 3D printing products. Suppose what happens, ma'am, that I'll try to explain it with the help of example.
Okay.
One example I took was of extrusion profile. One case we recently faced was that one extruded profile we are not getting manufactured in our unit, so we have to get it imported from foreign countries. So it is not possible for us to get it transferred, get it transportation from foreign location to here. So what they have done is they have made a same product, that what digital twins kind of, that they have made a same product by 3D printing product at our location, and on that we have performed our test, and based on that we have placed the order and we received that material. So in this context we are using the digital twins in our unit.
Okay, okay, because there is a lot of research going on this topic, digital
Yes,
twin.
ma'am. Yes, ma'am. Yes, ma'am.
Yeah, okay. So real factory conditions, you can simulate that.
Yes, ma'am. Yes, ma'am. We
Oh,
can do that, and which is very helpful without incorporating lots of material cost and saving our transportation and many things involved.
okay, okay, right. Thank you so much.
Thank you. Thank you, ma'am.
Any other queries?
Yes, ma'am.
Okay, Rashmi ma'am.
Good evening, sir.
गुड इवनिंग मैम.
सर जितना मुझे थोड़ा बहुत नॉलेज है उसके हिसाब से 3D प्रिंटर्स बहुत यूज होते हैं, जो मैकेनिकल कंपोनेंट्स होते हैं उनकी
ma'am.
मोल्डिंग और सिमुलेशन के लिए।
यस मैम.
तो वो 3D प्रिंटर्स में और क्या एडवांसमेंट हुआ है, हम लोग किस टाइप के मटेरियल्स उसमें यूज कर सकते हैं? और आप जैसे वो ब्रिज के बारे में बता रहे थे कि लाइट वेटेड ब्रिज है जिसको आप
Yes, ma'am.
मतलब कि उसके मैन्युफैक्चरिंग के बारे में बता रहे थे,
यस मैम.
तो वो सेफ्टी प्रिकॉशन के लिए अपन यूज कर रहे हैं, बट अगर वेट बहुत ज्यादा कम है तो क्या उनकी ड्यूरेबिलिटी बहुत टाइम तक होती है?
नहीं मैम, एक्चुअली कैसा है, जो बेसिक इंजीनियरिंग के जो कंसेप्ट्स हैं हम वही यूज करते हैं यहाँ पे. जैसे जैसे आपका ब्रिज का लेंथ बढ़ेगा आपकी लोड बियरिंग कैपेसिटी कम होती जाएगी, जो जनरल इंजीनियरिंग पर्पस है. तो हम लोग क्या करते हैं, हम लोग जो इनको प्रोडक्ट्स प्रोवाइड करते हैं ना, हम लोग स्टैंडर्डाइज प्रोडक्ट प्रोवाइड करते हैं जिसमें इंटरचेंजेबिलिटी होती है. वो उन्हीं प्रोडक्ट्स को यूज करके 10 मीटर्स 30 मीटर्स का भी ब्रिज बना सकते हैं. वो उन्हीं कंपोनेंट्स को यूज करके 100 मीटर्स का भी ब्रिज बना सकते हैं. जस्ट उनको सेम कंपोनेंट्स, सेम 15 और 25 टाइप्स ऑफ कंपोनेंट्स को मल्टीपल्स में यूज करके वो अपने ब्रिज की लेंथ कम या ज्यादा किया कर सकते हैं. और जब किसी बटालियन को या किसी भी यूनिट को, या आप किसी विलेज में अगर कहीं पे बाढ़ आ गई है या कहीं पे आपको ब्रिज लगाना है, तो ये पहले से कैलकुलेटेड रहता है कि यहाँ पे एक टाइम पे ट्रैफिक लोड कितना रहने वाला है, यहाँ पे कितने लोडेड ट्रक्स जाने वाले हैं, यहाँ पे टू व्हीलर्स ज्यादा चलने वाली है. तो एक लोड का कैलकुलेशन पहले से रहता है. और अगर जैसा आपका क्वेश्चन है, एक वहाँ पे सेफ्टी बोर्ड पहले ही रहता है कि आपके भाई इस स्पीड के ऊपर आपको चलना नहीं है. आपको इस अगर 2 व्हीकल्स जा रही हैं तो 2 व्हीकल्स पास होंगी, उसके बाद नेक्स्ट ऑपोजिट डायरेक्शन वहां से व्हीकल्स आएगी. तो ये जनरल इंस्ट्रक्शंस ब्रिज के साथ रहते हैं.
मतलब एक लिमिटेड एरिया के लिए वो प्रिफरेबल होगा, है ना?
लिमिटेड एरिया, एक्चुअली मैम टू टाइप्स के ब्रिज होते हैं. एक तो होता है ड्राई ब्रिज और एक होता है फ्लोटिंग ब्रिज. जो ड्राई ब्रिज होते हैं वो जो ड्राई कैनल्स रहते हैं, ट्रेंच रहते हैं, जिसमें दोनों एंड्स पे आपके ब्रिजेस लैंड पे सपोर्टेड रहेंगे, वो उस टाइप के ब्रिजेस रहते हैं. जो फ्लोटिंग ब्रिजेस रहते हैं ना, फ्लोटिंग ब्रिजेस में नीचे में रबर आइटम्स रहते हैं. रबर आइटम्स अपने आप में फ्लोट होते हैं, उसको इन्फ्लेट करते हैं एट द साइट विद द हेल्प ऑफ फिलिंग यूनिट. कंप्रेसर यूनिट्स हम लोग यूज करते हैं. एट द साइट आप किसी भी फ्लड एरिया पे लेके चले जाइए, हिली एरिया पे लेके चले जाइए, वॉर एरिया पे लेके चले जाइए. वहां पे आप फिलिंग यूनिट से जो रबर के फ्लोट्स रहते हैं उनको आप इन्फ्लेट कर दीजिए. वो विद इन 7 to 8 मिनट्स हो जाते हैं. एंड आप उसके ऊपर फिर जो अपना मेटल जो इंफ्रास्ट्रक्चर है ब्रिज का, उसको मैन्युफैक्चर, आप उसको इरेक्शन वहां पे कर सकते हैं. और उसके बाद उसकी जो लोड, जो मैं आपको एक थ्योरेटिकल मैं आपको बता देता हूँ, उससे शायद आपको आइडिया हो जाए. अगर 13 मीटर का ब्रिज है, 13 मीटर्स का ब्रिज है, ड्राई ब्रिज है, तो उस पर आप 20 टन की कैपेसिटी के साथ अपना पूरा बटालियन लेके ट्रैवल कर सकते हैं. आप नॉर्मल जो अपनी सिटी का जो ट्रैफिक है वो तो आराम से उससे क्रॉस ओवर हो जाएगा. अगर 100 मीटर्स का ब्रिज है तो उसमें 70 टन की कैपेसिटी की आपकी लोड ट्रैवलिंग हो सकती है. लेकिन उसमें कैसा रहता है, अगर उस पे से आप अगर टैंक्स ट्रैवल हो रहे हैं तो टैंक्स फिर उसको जर्क नहीं देना है वहां पे. ये जो बेसिक से प्रिकॉशंस रहते हैं ये फॉलो करना पड़ता है.
और सर आप वो ट्विन्स के बारे में कुछ बता रहे थे, वो जनरली
जी जी
प्रोडक्ट के बारे में है क्या, या फिर कुछ सिमुलेटर्स के लिए, सिमुलेटर्स के थ्रू हम कुछ ड्रॉ कर रहे हैं या बना रहे हैं जो
हम लोग
न्यू प्रोडक्ट्स है उसके कंपोनेंट्स वगैरह को,
हम
तो
लोग कैसा
उनके
करते हैं,
लिए
जी हम लोग कैसा
उनके
करते
लिए
हैं मैम,
ट्विन
जो
यूज करते हैं?
ओरिजिनल जो प्रोडक्ट रहता है, ओरिजिनल प्रोडक्ट के मटेरियल के साथ हम डेविएट नहीं कर सकते. तो उस ओरिजिनल प्रोडक्ट्स को मैन्युफैक्चर करने के पहले उस पे, जैसा आपने बताया, सिमुलेट करने के लिए, आप लोग की टर्मिनोलॉजी में जो सिमुलेट करने के लिए, हम लोग उस पे सारे प्रोसेसेस जो भी इन्वॉल्व हैं वो सारे प्रोसेसेस उसमें इनकॉर्पोरेट करने के लिए हम लोग वैसा एक प्रोटोटाइप बनाते हैं विद द हेल्प ऑफ डिजिटल ट्विन्स. और उसमें हम वो प्रोसेसिंग करके देख लेते हैं कि भाई हमारे जितने भी जिग्स हैं, फिक्सचर्स हैं, जितने भी टूलिंग्स हैं, उनकी सब कंपैटिबिलिटी इस प्रोडक्ट के साथ, इसके पर्टिकुलर डायमेंशंस के साथ मैच हो रही है नहीं हो रही है. हम लोग पूरे कंपोनेंट को विद द हेल्प ऑफ डिजिटल ट्विन्स रिप्लेस नहीं करते हैं. हम लोग बस उसका, जैसा आपने बोला, सिमुलेशन के लिए हम लोग यूज करते हैं.
तो प्रैक्टिकल इम्प्लीमेंटेशन के लिए टाइम है उसके लिए?
प्रैक्टिकल इम्प्लीमेंटेशन के लिए टाइम है मैम. उसके लिए तो फिर 3D प्रिंटिंग या डिजिटल ट्विन में वो मटेरियल पहले आना जरूरी है. क्योंकि यहाँ पे मैम अभी कैसा हो गया है, जो डॉक्यूमेंट्स बने हैं ना, जैसे मैं जिस कंपोनेंट्स की बात कर रहा हूँ, इनके जो डॉक्यूमेंट्स बने, ये सारे डॉक्यूमेंट्स यहाँ से ऑलमोस्ट 70 ईयर्स 80 ईयर्स प्रायर बने हुए हैं. इन डॉक्यूमेंट्स में कभी कोई चेंजेस हुए नहीं है, जो हर इंडस्ट्रीज में होता है. तो इन डॉक्यूमेंट्स में जो मटेरियल स्पेसिफाइड है वो बहुत सारे मटेरियल आज की डेट में ऑब्सोलीट हो चुके हैं, वो मटेरियल आज मिल भी नहीं रहे हैं मार्केट में। तो हमारे लिए इतनी मुश्किल हो जाती है कि उसका ऑल्टरनेट मटेरियल ढूंढना। अब आप उसका ऑल्टरनेट मटेरियल तो आपको फिर भी मिल जाएगा, उसके सारे स्पेसिफिकेशंस, उसके सारे लोड जो कैलकुलेशंस होने चाहिए वो सब भी मैच करने चाहिए। तो हमको मटेरियल मिल गया लेकिन उसकी जो प्रॉपर्टीज आ रही है वो मैच नहीं कर रही है, तो हम तो ऑलरेडी वी आर फेसिंग प्रॉब्लम इन फाइंडिंग द ऑल्टरनेट मटेरियल। देन इट विल बी वेरी डिफिकल्ट दैट हम 3D प्रिंटिंग वाले मटेरियल में वो मटेरियल हमारा जो सारी प्रॉपर्टीज हैं, टेस्ट लोड कैपेसिटीज हैं, टेस्ट पैरामीटर्स हैं, वो सारे फुलफिल हों। तो अभी तो टाइम लग सकता है मैम मेरे हिसाब से उसमें, मतलब मेरा जो स्कोप है जानकारी का उसमें अभी टाइम लग सकता है। अगर रिसर्च में कहीं हो रहा है और ये रिसेंटली हो जाता है तो ये तो हम लोगों के लिए भी बहुत बेनिफिशियल होगा।
सर एक और क्वेश्चन है
जी।
ये आप कुछ जो स्टूडेंट्स हैं उनके लिए प्रोजेक्ट वर्क का कुछ बता रहे थे आप कि
Yes,
आप
ma'am.
लोग कम्युनिटी के
कैसा होता
साथ में मिलकर कुछ वो लोग कर रहे हैं जो।
यस मैम, कैसा होता है, जैसे मैं भिलाई के रायपुर के कॉलेज में मैंने पढ़ाया 2 साल। हम लोग भी इंडस्ट्रियल ट्रेनिंग के लिए हम अपने यूजी के समय भी हम लोग सब जाते हैं, फिर स्टूडेंट्स को भी लेके जाते हैं। जब मैं यहाँ इस ऑर्गेनाइजेशन में मैंने ज्वाइन किया तो हमारे साथ हम जो कंपोनेंट्स बनाते हैं ना, इसमें एक डायनामिक लोड टेस्टिंग होता है। ये डायनामिक लोड टेस्टिंग के लिए उस टाइम के जो लोग थे इन्होंने 2-3 कॉलेजेस को ऑथराइज किया। तो बीइंग पोस्टेड एट अंबाझरी नागपुर, एक आईआईटी मद्रास था और एक वीएनआईटी नागपुर था। तो हम जो भी कंपोनेंट्स मैन्युफैक्चर करते हैं, हमारा जो इंस्पेक्टोरेट है उसने एक थर्ड पार्टी को इनकॉर्पोरेट करके रखा है बीच में कि आप जो भी कंपोनेंट्स मैन्युफैक्चर करोगे उसका जो लोड टेस्टिंग है वो आप वीएनआईटी के प्रोफेसर्स के थ्रू करवाओ। उसका लोड टेस्टिंग, उसका लोड कर्व बनेगा, उसके बेसिस पे हम बताएंगे कि उस उतना पर्टिकुलर लोड साइकिल कंपोनेंट पे चलने के बाद वो कंपोनेंट आपका पास हुआ या फेल हुआ। तो इस पर्पस के लिए हम लोग रेगुलर बेसिस पे वहाँ पे जा रहे थे। तो वहाँ पे कुछ पीएचडी के स्टूडेंट्स भी थे और एमटेक वाले भी थे, तो उन्होंने इंटरेस्ट दिखाया। तो मैंने बोला कि आप अपने फैकल्टीज के थ्रू आप फैक्ट्री में अप्रोच करिए। तो उनके फैकल्टीज का जो उनके कोऑर्डिनेटर थे जो हमारा टेस्ट परफॉर्म करते थे, उन्होंने एक ऐसा प्रोजेक्ट अपने हाथों में लिया और फिर अभी काम कर रहे हैं उसमें। कुछ हुआ तो नहीं है अभी प्रोग्रेस, उनकी तरफ से कोई सबमिशन नहीं है, पर ऐसा होगा तो वो आगे बढ़ेगा वैसा। तो पॉसिबिलिटीज तो है। आप
जी 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 सर, प्लीज कंटिन्यू।
पॉसिबिलिटीज तो है मैम, अगर अप्रोच करेंगे तो। यानी हम तो डे टू डे लाइफ में इतने सारे प्रॉब्लम्स को फेस करते हैं मैम कि हर चीज़ के लिए एक छोटा सा पर्टिकुलर प्रोजेक्ट बन जाए और उसमें कोई सॉल्यूशन निकल जाए तो हम लोग तो बहुत हेल्पफुल रहते हैं उसके लिए। तो अगर कहीं हम लोगों को भी मौका मिले तो ये हमारे लिए भी बहुत अच्छा है और स्टूडेंट्स को सीखने मिल रहा है तो उनके लिए भी वेल एंड गुड।
सर आप लोग जो सप्लाई चेन यूनिट है आपका, उसमें किस तरीके से इसको यूज कर रहे हैं आप लोग?
मैम हम लोग का एक्चुअली कैसा रहता है, हम लोग डिपो में सप्लाई करते हैं। हम लोगों का कैसा रहता है, जब हमारा कंपोनेंट कोई भी पास होता है, पास होने के बाद ईच एंड एवरी कंपोनेंट में एक सील एंड साइन लगता है हमारे इंस्पेक्टोरेट का। उसके बाद वो डिपो में जाता है। तो हम लोगों के पास कोई भी कंपोनेंट पास होने के बाद आपको विद इन 10 to 15 डेज हमारे पास वो स्टे नहीं करता, क्योंकि उसका स्टोरेज का भी एक प्रोसेस है, उनको स्टोरेज का प्रोसेस भी वो फॉलो करना है। तो हम लोग जब कोई भी कंपोनेंट मैन्युफैक्चर करते हैं उसका इंस्पेक्शन हो जाता है, उसके बाद हमको जल्दी से जल्दी उनका जो भी कंसाइनमेंट जो यूनिट है वहाँ पे हमको उसको शिफ्ट करके देना है। उसके बाद उनकी शेल्फ लाइफ रहती है, वो शेल्फ लाइफ में हम वारंटी गारंटी देते हैं। तो उनको वो सारे शेल्फ लाइफ जो स्टोरेज की जो कंडीशंस है, वो फिर रबर आइटम्स हो, स्टील आइटम्स हो, एल्यूमिनियम आइटम्स हो, उनको मेंटेन करना पड़ता है। तो हम अपने पास उसको डिले नहीं रखते, हम मैन्युफैक्चर होने के बाद उसको तुरंत डिस्पैच कर देते हैं कंसाइनी को।
ओके, थैंक यू सो मच सर।
जी थैंक यू मैम, थैंक यू।
जी जी थैंक यू। स्वाति मैम कंटिन्यू करिए आप।
Your microphone is mute, Swati madam.
Okay. Sorry. Any other queries? Okay, so thank you, sir. Thank you very much for your insightful and enriching session. Your talk has given us a deeper understanding of how artificial intelligence is now revolutionizing production systems and or also enhancing the precision, quality, and efficiency in modern day tech manufacturing. and the clarity and the practicality, and by giving the practical examples with each you with which you explained each concepts, have made the sessions immensely beneficial, I'm sure, for both the faculty and the researchers which have joined with us in this FDP. We sincerely appreciate the time and effort you took to share your valuable experience and expertise with us, sir. And so, on behalf of the organizing committee and all the participants, I extend the heartfelt gratitude to you. And we are sure we look forward to continue many more enriching conversations with you ahead in the future, sir.
Thank you,
Hoping
ma'am.
to join with you or continue with your sessions in coming FDPs or any other programs, sir.
Thank you.
Thank you for giving your valuable time.
Thank you, ma'am. I myself want to thank the team of whole Shankara group, and I myself consider myself one amongst you. I have also learned from you by for preparing for you. I have gone through many things that I was neglecting, so it was beneficial for me too, ma'am.
Yes,
Thank
yes,
you.
yes, yes. Thank you, sir. Thank you so
Thank
much
you.
for joining with us, sir.
Thank you so much.
Thank you, sir. So, okay, so participants, I'm sharing the WhatsApp feedback link in the chat box and in the WhatsApp too. And so this is the end of our today's sessions. And one more thing I need to share, that tomorrow is the last day of our FDP, 6-day FDP, and tomorrow is Sunday. So our session will start from 2 p.m. We have continued 3 sessions, which will be a session 11, 12, and 13. And the first session will start at 2 p.m. To 3:30, then 3:30 to 5, and then the last session will be 5 p.m. to 6:30 p.m. And our expert will be from New York, so New York-based AI influencers, entrepreneur. So I request you all to join sharp at 2 p.m. afternoon for our next session, and at the end of the session from the 6:30 p.m. we will have our online test. We will share the test link with you all. It is a multiple choice questions, and it will be easy. I don't say, but you have to score at least 70% to get the certificate from as per the guidelines of AICTE. And one more thing, in the Atal portal in which you have done the registration, there is a feedback form which you have to positively fill the feedback there. All this feedback link which we are sharing at the end of the session, it's for our and attendance purpose and feedback purpose. But for to get the certificate, you have to fill the feedback form in the AICT portal in which you all have done the registration. So that is compulsory. That is, you have to done it to get the certificate. Then only you will get the certificate after filling the feedback form. So please uh, don't miss the feedback form which is available in the AICT portal. Okay, and the test link we will share at the 6:30 p.m. tomorrow. And after that, from the 7:30, we will have our valedictory session of the FDP. So to as we are ending our FDP tomorrow. So from 7:30, we will have a short valedictory session. So I request all of you to join with us tomorrow. That is the last day of our FDP. So thank you. In case of any doubt, you can ask us in the WhatsApp. Okay. So please keep in mind, tomorrow we will have a session from the afternoon 2 p.m. and in the evening we will have a test and a feedback, and then we will end our FDP program with the valedictory session. So thank you everyone.
Madam, one doubt, madam. When the feedback link will be available in Atal FDP website?
From tomorrow you can fill the form, sir.
In Atal FDP login
Yes,
also?
yes, sir. Yes, sir.
Tomorrow after 2 o'clock, after
Yeah.
3 o'clock.
Yes, sir.
Thank you.
I will also remind you tomorrow.
Okay, ma'am.
Yes, sir. Tomorrow after the session, so you can fill the feedback form in the AICT portal. Yes. Okay, so thank you everyone. Thank you for joining with us and for making this FDP successful. Tomorrow is the last day, so please be with us. Thank you everyone for giving your valuable time.
Thank you, ma'am. Thank you.
Tomorrow, anyhow, however, Sunday, so it's available for all of us.
Yeah, it's Sunday, and we have 3 sessions back to back
Yeah,
from 2 to
so
6:30 p.m.
definitely will attend last
Yes, sir. Yes, sir.
Sunday, also free day.
Yeah, it's Sunday. It's a free day. So 2 p.m. from 2 p.m. we will start our sessions, sir.
Okay, ma'am. Thank you.
Okay. Thank you, sir. Okay, thank you once again. We are ending the beat here. Thank you.